All right. So, discrete math. This is actually our last method that we're going to talk about for elections and so for voting theory. And so, the method we're going to talk about today is going to be what's called the method of pairwise comparisons. Pretty simple one. Hopefully, it won't take too long to kind of talk you through. So, in pairwise comparisons, every candidate is going to be matched head to head against the winner of, or against every other candidate. Each of these head-to-head matches is going to be called a pairwise comparison. So in a pairwise comparison between candidates X and Y, every vote is going to be assigned to either X or Y, and the vote going to whichever of the two candidates is listed higher on the ballot. So the winner is going to be the one with the most votes. If the two candidates split the votes equally, then the pairwise comparison ends a tie. To score it, the winner of each pairwise comparison gets 1 point. The loser gets none, and in the case of a tie, each candidate gets a half a point. The winner of the election is the candidate with the most points after all the pairwise comparisons are tabulated. Overall point ties in this method are very common, and so as with other methods, there's going to be a tie-breaking procedure which is determined beforehand. Unless, of course, multiple winners are allowed, in which case the tie will stand. Okay, so to illustrate this, we're going to do the pairwise comparison for the math club election. We're going to start by comparing A and B. We're going to think of A as the red candidate, B as the blue candidate. That way we can more clearly see it. The other candidates will not come to the picture at all. So in other words, on this screen right here, C and D do not matter. So if you wanted to, you could even cross them off. They don't matter whatsoever. We are going to focus on A and B. And again, the color coding makes it quite a bit easier to see. Notice that A only wins these 14 votes at the very beginning. In every other case, B is higher. They receive more votes than A does. So if you tally that up, that means for A, you only have 14 votes, whereas for B, 18 plus 4 is 22, plus 1 is 23. That means that B is the winner. That means that they earn 1 point towards winning this election, which is what this slide describes for you. If you want to go back and read it, you're more than welcome to. Let's now do the same thing but between C and D. So now instead of comparing A and B, we're going to focus on C and D. I'm just going to go ahead and cross off A and B since we're not going to consider them at all. Okay, so between C and D, let's kind of tally up where they are at. And again, the color coding makes it kind of nice. So C ends up winning in these three places. 14 plus 10 is 24, plus 1 is 25, whereas D only wins in two places, and 8 plus 4 is 12. That makes C the winner here, so we'll add a point for them. And again, if you want to read through this slide, that's essentially what it's telling you. So if you do that for all of the candidates one at a time, or well, really two at a time, we end up with the following scoreboard. Is that A versus B, B got the point. A versus C, C gets the point. A versus D, D gets the point. B versus C, C gets the point. B versus D, B gets a point. And C versus D, C gets a point. So, looking at our scoreboard, if you want to think about it that way, B has a total of 2 points, C has a total of 3 points, and D has a total of 1 point. That makes C our winner. Okay, so again, here is what that was saying. The winner of our election under this method is Carmen. In other words, this method of pairwise comparison satisfies all three of the fairness criteria that are discussed so far in the chapter, but it's a new winner. And if you think about it, every method that we've looked at has produced a different winner. Plurality method produced A. Our Borda comparison produced B. Our plurality with elimination produced D, and now we've got C. So it seems like whichever method we use, we're going to end up with a different winner. And that'll be something we'll talk about later on in this chapter. So, how many pairwise comparisons do you have to do? One practical difficulty is that the number of pairwise comparisons grows very fast as the number of candidates grows. So if you have 5 candidates, you only have a total of 10 pairwise comparisons. If you have 10, you actually have a total of 45, and by the time you get to 100 candidates, which would be a lot for an election, you have 4,950 pairwise comparisons that you'd have to do. So in order to help out with kind of knowing how many comparisons there are, as well as how to add up the numbers, more quickly. For the sum of consecutive integers, here's that formula. So if you're adding 1 plus 2 plus 3 all the way up to some number L, then you would just take the last number L multiplied by L plus 1 and divide by 2. As for your number of pairwise comparisons, in an election that has n candidates, the total number of pairwise comparisons is n minus 1 multiplied by n over 2. So imagine that you were going to be working a round-robin tournament. So in a round-robin tournament, every player plays every other team exactly once. So imagine you're in charge of scheduling this for a ping pong tournament with 32 players. The tournament organizer agrees to pay you $1 per match for running the tournament. Since you want to know how much you're going to make, and since this would work as a pairwise comparison, we can use the formula we just discussed. So again, that formula was to take n multiplied by n minus 1 all over 2. So what that would be is you would take 32 multiplied by 32 minus 1 over 2, which becomes 32 multiplied by 31 over 2, and that's this right here. It turns out that there's going to be 496 matches paid, which ends up being $496 that you'd make as the tournament director. Not a bad gig for a weekend job. All right, guys. That is it for our methods. Our last section is going to talk about fairness criteria as well as Arrow's impossibility theorem. That'll be it for this chapter, and then we'll look at chapter quiz next Wednesday. Have a good one.